chain rule. If f is a differentiable function of u and u is a differentiable function of x, then the composite f of u is a differentiable function of x, and the derivative of f of u is equal to f prime of u times du dx, or df dx equals df du dx. Essentially, the derivative of f of something is the derivative of f evaluated at that something times the derivative of the something. So for example, the derivative with respect to x of u squared is 2u du dx. So the original rule to differentiate something to a power, or x squared, would be that the derivative of x squared is 2x. If instead of x we have a function, the generalized rule is the derivative of u squared is 2u du dx. Similarly, instead of the derivative of x cubed being 3x squared, the derivative of u cubed is 3u squared du dx. Instead of talking about the derivative of 1 over x being negative 1 over x squared, the derivative of 1 over u is negative 1 over u squared du dx, and so on. Here we're going to differentiate 2x squared plus x quantity cubed. Now this is a composite function with the outside function being something cubed and the inside function being the 2x squared plus x. So we begin by taking the derivative of the outside function. So the 3 comes out front. We leave the inside alone, 2x squared plus x, and subtract 1 from the exponent, so the power of 2. We multiply then by the derivative of the inside function, the 2x squared plus x. Differentiating that, we end up with 3 times 2x squared plus x squared times 4x plus 1. As another example, let's differentiate x cubed plus x to the power of 100. Again, we've got a composite function where we've got some function, in this case x cubed plus x, raised to the power of 100. So something to the 100 is the outsidemost function. And so the derivative here is going to be 100 times, we're going to leave the inside function alone, x cubed plus x, to the power of 99 times the derivative of the inside, x cubed plus x. And that derivative we know is 3x squared plus 1. As another example, let's differentiate the root of 3x plus 1. It might be easier to rewrite this as 3x plus 1 to the power of a half. And again, we see that this is a power rule. So the half comes down, leave the 3x plus 1 alone to the power of negative a half times the derivative of the inside, the 3x plus 1. And the derivative of 3x plus 1 is 3, so we end up with 3 halves times 3x plus 1 to the negative a half. Next, we want to differentiate absolute value of 4x squared minus x. Here, the outside function is going to be the absolute value, and the inside function is going to be the 4x squared minus x. So as before, we're going to differentiate the outside function. So we get absolute value 4x squared minus x divided by 4x squared minus x times the derivative of the inside. The derivative of the inside is 8x minus 1. Annual profit is given by P equals 1000 q to the 0.5 plus 5q, where q is the number of widgets sold each year. The number of widgets the company can manufacture each year depends on a number n of assembly line workers it employs, according to the equation q equals 20,000 n minus 100 n squared minus n cubed. Use the chain rule to find the marginal profit at an employment level of 20 workers and interpret the answer. The chain rule tells us that dp dn should be dp dq times dq dn. dp dq is equal to 500q to the negative a half plus 5. dq dn is 20,000 minus 200n minus 3n squared. Putting this all in terms of n's, we get 500 times 20,000 n minus 100n squared minus n cubed to the power of negative a half plus 5 times 20,000 minus 200n minus 3n squared. And evaluating this at n equals 20, we get approximately $86,000.